Good afternoon, all. Today I'm going to just give an introduction on memory devices and microprocessor, which is course number 7 of MSc Physics for second year students. This particular paper consists of 7 blocks. This will have block 1 as logic families, semiconductor memories, Intel 8085 microprocessor, and its architecture and organization. And block 4 comes as addressing modes and programming of 8085 microprocessor and peripheral devices and its interfacing. The Intel 8086 also discussed in block number 6 and block 7 advanced microprocessors, which will be discussed. So in block 1, the logic families will be discussed in detail in the next class, and the subsequent blocks also discussed in the coming units. So today I'm going to give only a fundamentals of the this particular paper, which will be useful in understanding the other parts of the unit blocks. So let us discuss certain things which is about the microprocessor today. So the microprocessor is a central processing unit which will be is the main part in the computer, which will consist of a microcomputer consisting of input devices and output devices and memory devices, and then you have the central processing unit as a microprocessor. So this particular uh, uh, to understand the microprocessor, we need to uh, discuss the input devices, output devices, some of the memory devices also we have to understand. Some of the input devices like microphone is also an input device, a keyboard is an input device, and the jockey is also. So these all are input devices, and then some of the output devices are the speakers, and then uh, mm, the printers and my speaker. These are all the some of the output devices. So once the microprocessor takes the input signal, then it processes it, and it sends the get the information from the memory by sending the address bus and data bus and then control lines. Then the it processes it and then send to the output device. So this is how a human being does things like looking from the eyes, then recognizing the object that is processed in our brain, then again it process it, and again uh, from the mouth we say something out. So we have to search in the brain. Suppose if you look at the some object, so what we do, we'll process it whether we have seen that person earlier or not. uh, then if it is seen, then it searches in our mind, so when we have seen what is his name and all. So then it process it, and then we can say that we can identify, and we can say name of the person and all. So like that, the it will be recognized and they process it. So it's similar in the same lines, the microprocessor also does the same things, take the input information, take the data from the memory, process it, and then send back to the output device. This is what all happens. So for this, it requires some of the interfacing devices like 8255, 8155, and keyboard 8279, 8259, 8257. These are all the ICs that are interfacing along with this CPU, so that combination of these ICs and the microprocessor and the memory, it is all together, we call it as a microcomputer. So basically, the coming to the fundamentals of this 805, it is designed long back since 1974 by the Intel Corporation, and this is a solid state chip. Then subsequently, they invented, they manufactured, designed 8086, then 80286, then 80386, then 80486, then Pentium processors, then Celeron, and then Core 2 Duo, and then now i3, i4, i5, i7, etc. So all these devices which are uh, now we are using i5s and i7s and i3s and the different generations we have to. Once we understand the fundamental devices like 8085, 8086, so we can also discuss these things very easily. We can understand the basic things. So coming back to 8085, so this particular 8085, it runs only with the it understands only zeros and ones. What are zeros and ones? It's a binary operation, 0 and 1. This is called um, this understand machine language. It's a machine language. So assembly, it recognizes this assembly language, and then it processes it, it converts into binary, and then it will be understood by the processor, then it gives the output. So for to understand this 8085, what we have to do, we have to understand the hexadecimal numbers. So English, like what we are assembly language program we have to learn, and then uh, once the program will be written in the assembly language, and then we have to program it by putting the data into the keyboard, and then it will be processed it, and then you get the output in a keyboard only. So all this is a hexadecimal keyboard is, and display is also will get in a hexadecimal, output also will get in hexadecimal number. So before we enter into the microprocessor, we have to understand the hexadecimal system also. This hexadecimal system coming like binary, the and decimal system, we have hexadecimal system. So 0 to 9 is considered as a decimal system, zeros and ones is a binary system, and octal system is 0 to 7, and similarly the hexadecimal number is 0 to 9, then A to F. So all these coming from 0 to F, which together is a hexadecimal numbers. Then we have to understand all these system, then only we can write some programs, and then we can understand in detail. So this will be discussed in one of the classes, the number systems, and then we can understand the programming. So to understand the program, you will have some set instruction set also there. This instruction set uh, consists of various sections like data transfer instructions, and arithmetic and logic instructions, branch instructions, and machine and IO instructions. So this total instruction set of 106 instructions are there. These are divided into these 5 different types, like data transfer, arithmetic instructions, logic instructions, branch instructions, then machine and IO control instructions. So once you understand one by one all these instructions, we can start writing the program. To start with simple the program, taking some instructions, we can understand, and then we can write some programs one by one onwards. After understanding this 8085 working and its architecture, we once you understand the internal architecture of that one, then only we can understand the next 8086, and then after that 80286, 80386, and 80486, and thereon. So these are the important things that we have to understand before uh, completing this. So by finally we can go one by one. So the first two units is talking about the logic families. This logic families chip making. So how the a chip is manufactured as a thin films, which is coated with the semiconductor material, and then it will be very thin layer. This is of different logics, TTL logic and CMOS logic. CMOS is nothing but the complementary metal oxide semiconductors. So in this families like TTL logic, you have diode transistor logic, transistor transistor logic, and emitter coupled logic. So in this DTL nowadays they are not using. So then TTL uses for most popularly for SSI and MSI. SSI is the small scale integration, and MSI is the medium scale integration. So if this MSI, so 2 to 100 gates per chip will be there. So if it is made up of small scale integration, in a single IC, few 12 gates for the one chip will be there for SSI. For large scale integration, it is more than 100 gates per chips are sandwiched in the thin film, so that the process will be. So this is anyway, this TTL is used only in the low speed devices only. So the two basic techniques for manufacturing ICs are bipolar and metal oxide semiconductor. The first fabricates bipolar transistors on a chip. The second MOS field effect transistors. Bipolar transistor is a preferred for small scale integration and medium scale integration because it is faster. Metal oxide semiconductor technology dominates large scale integration field because more MOSFETs can be packed into the same chip area. A digital family is a group of compatible devices with the same logic levels and supply voltages. The word compatible means that you can connect the output of the one of the devices to the input of the another. With the devices of a digital family, we can create a wide variety of logic families circuits. So in the similar way, these we have MOS families. So PMOS, NMOS, and CMOS. These are the three different MOS families. So PMOS is nothing but P-channel metal oxide semiconductor field effect transistor, and NMOS is the N-channel metal oxide field effect transistors, and CMOS is the complementary metal oxide semiconductor field effect transistor. So the oldest and the slowest type is PMOS, and nowadays they are not using. And NMOS is for LSI, for large scale integration field. It is used, and for microprocessors and memories, this NMOS will be used. Whereas CMOS, a push-pull amplifier, push-pull arrangement of N and P channel MOSFETs is exclusively used where low power consumption is needed. As in packet calculators and all, it will be used. So these things are some of the fundamentals that we understand in detail in the next class. And memory chip memories and different types of memories. Basically there are two memories are there. One is a temporary memory, another one is a permanent memory. And in temporary memory, it is called RAM, random access memory, and permanent memory are read-only memory. The read-only memories are different types. You that is EPROMs, PROMs, and E-square PROMs. So PROMs is programmable read-only memory. EPROMs is the electrically programmed read-only memory, and D-square PROMs is electrically erasable programmable read-only memory. So this electrically erasable is once it is exposed to UV light, then data will be erased completely. And third category E-square EPROMs, which is electrically erasable programmed read-only memory. So this electric high voltage is supplied so that it will be raised and completely, and then we can write the programs. Basically, These prompts are basically used in storing the monitor program in any of the computers or in any system which will be written the BIOS programs or the monitor programs. It will be written in that and kept it aside, and it will not be, user cannot use this. So once you we understand the memory mapping. So how the total memory is divided into how many slots. So what are the different places? The memory mapping will give us very clear area. Some of the area is used for the user, and some area is used for the program for BIOS programming. So all these data will be stored in the different areas. So basically, this address of this memory, basically memory will have some address and a memory. So address is of, for example, if you look at 8085, it is a 16-bit address. So in the hexadecimal number, if you look at 0000, that is 4 zeros, each one hexadecimal are equal to 4 binary bits. So 4 hexadecimal numbers is equal to 16 binary bits. So the total memory area starting from 0000 to FFFF. So total 64 kilobytes of memory we can address. We can store some data in this particular memory location, in this memory. So data bus is 8 bit and address bus is of 16 bit. So that this 8085 is called the 8 bit device, 8-bit device. Whereas 8086 is a 16-bit, and the address bus is a 20 bits. So this will have higher memory capacity. 1 megabits of data can be stored in the 8086. Whereas coming to the 286 and 386 and 486, it will be still higher. They are all of 32 bit, whereas 8086 is 16 bit and is 8085 is a 8-bit processor. So this is all from the 1974 from onwards till today. That is 83, I5 and I7, which is of 64-bit nowadays we are using. So this is all about brief introduction about the paper microprocessor and paper 3, I think it is. So I'll stop here.